Hello everyone, my name is Nidamarthi and this screencast is part of my MongoDB project based on the genealogist consultation sessions. So the purpose of this project is to build a Mongo database that stores the information about the consultation sessions which are provided by the genealogist to the clients seeking family history, advice and the research support. And also in this project, genealogists provide the family history services to the clients, and also the consultations may involve the Irish related family history challenges, and the genealogists are based in the Ireland, USA, England and the Australia. So here the database stores the consultation details such as the consultation year, consultation mode, topics, etc. And also it uses the two embedded documents, one is genealogist and one is client. So and also we can clearly see that the database also contains the array fields such as the consultation mode, record types used and the genealogist or specialization. So these arrays are very important because one consultation can involve multiple topics and multiple consultation modes and multiple record types. So to going further, to import the database into the Mongo shell, first we need to prepare the data and then we need to convert into the JSON format. So let me show you the JSON format which I have created to import into the Mongo shell. So this is my JSON document. Here we can clearly see that I details, consultation, year, duration, and also we can clearly see the embedded documents such as the genealogist and then the client here. So I collected the data and then I formatted into a particular format to be imported into the Mongo shell, and then I just removed the tab spaces between them and then I finally saved the file as JSON. So now it is ready for importing. So now I import the command prompt to import the JSON file into the MongoDB. So before running the aggregation query, I am showing how the JSON data was imported into the MongoDB. I used the MongoDB database tools here using, and also I use the mongo import command and then the file path of my JSON file and then the database name which is consultation DB followed by the collection name which is consultation JSON array, and then I dropped. We can clearly see that the 1000 documents which are imported successfully and 0 documents are failed to import. So it was the dataset here is ready for the analysis. So now I open the Mongo shell here. So I first use the consultation DB which is my collection name. So it is showing that we switch it to the database which is consultation DB, and then I am verifying the database and the collection using show databases. So it is showing my database which is consultation DB, and then I am now typing the show collections. So it is showing only my consultation because I switched only to this database. It should have to show only one consultation that you are working on. So now I am counting the number of the documents which is which can be written as db.consultation.count documents. Documents. So it should show the 1000. So I verify that I am working with the current database and the collection, and the count documents command confirms that the consultation collection contains the 1000 documents matching the import result which I have shown earlier. Now I will show you some sample documents with a pretty using pretty. So for that we need to write db.consultation db.consultation.find limit of the 3 pretty. So here I used the limit of the 3 to show the first only 3 sample database. So it should have to show the first 3 IDs. So before starting the aggregation, I am using the dot pretty here to show 3 sample documents in the readable format here. So this gives a clear view of the structure and the collection, and the document also contains the standard fields such as the consultation year, duration, hourly rate, other cost, payment status, report delivery method, DNA use, and it also includes the embedded documents such as the genealogist and the client. So now we imported and then we checked it. Now I just run the one aggregation query to check whether the data was running and producing accurate results. So now the simple aggregation which I am running is here, which is the question 6. So here the aim is to break the record types used array into individual record types and count how often each record type is used and calculate the average estimated income for each record type, and then sort the record type output so that the most frequently used record types appear the first. So this is one of the good aggregation question example because it uses an array field and requires unwind and project, group, sum, average, round and sort. So let me break down this question into stage by stage, and then I will explain you what each stage is doing exactly. So this is the stage 1, which is unwind. So this is needed here because the record types used is an array, and also a single consultation may include more than one record type, for example birth, census, death or employment. And also using unwind separates each value inside the record types used array into own document in the aggregation pipeline. So this is very important because I want to count the each record type individually. Without unwind, MongoDB would treat the full array as one combined value, and also which would not give an accurate frequency count. So let me just run this. So we can clearly see it had printed all the documents. So now if you want more, just type it for more. And then coming to the second stage. So here the second stage which I used was that dollar project, because this stage controls what fields are shown in the pipeline output, and I keep the record types used field because that is the main field which we are mainly focusing on and we are analyzing on. And also I calculated a created field called the estimated income here, because it is calculated using the formula duration multiplied into hourly rate plus other costs. So in the MongoDB syntax, underscore multiply calculates duration into hourly rate, and underscore adds other costs. So at this point, each separated record type now has an estimated income value attached to it. So see, we can clearly see each estimated income and the record type used and then the particular ID. Now coming to the stage 3. Now the third stage, which is group. This is the main summary stage of the aggregation, and I group the data by the records of types used. So each record type becomes one summary result. So let me see the output. We can clearly see the average income uses count, and average income uses dot average of function here to calculate the average estimated income for consultations involving each record type. And also at this stage, the output changes from individual consultation documents to group summary results. Now coming to the stage 4, we used the dot project with the round. So here we can clearly see that this stage improves the readability of the output, because see it, we can clearly see the values here. So this doesn't change the analysis itself, but it makes the results very cleaner and more suitable for the report. Now coming to the stage 4, I used here is the sort function, and then when running the output we can clearly see the final output gives the ranked summary types across the consultation databases, and this is very useful for a data analytics perspective because it shows which genealogical record types are most frequently used in the consultations, and while also showing the average income associated with each record type. So we got our output in the above, but here I am just doing one small change to demonstrate the impact of the changing one stage. I changed the final sort here. So instead of sorting by usage count, I now sort by the average income. Here we used the sort by usage income count, and then I am just running it here. So we can clearly say that this changes the purpose of the output, and the previous version answered which record types are the most frequently used. So this version answers the record types have the highest average income. So this shows how changing one state can change the analytical meaning of the result. So this is the final output of that aggregation question. So finally I can say that this aggregation demonstrates the several important features of the MongoDB aggregation framework, because it uses the unwind to break apart an array, and dollar project to control the output and calculate the estimated income, and dollar multiply and add dollar add for financial calculation, and the group function to summarize by record type, and the sum function to count the uses, and also the average to calculate the average income, and then the round to clean the output, and finally the sort to rank the final result. So this example is very strong because it shows how MongoDB can convert the document-based consultation data into analytical summaries. Thank you.